Wow, thank you.
All right, so again, this is how we do that first one, number 3, and then this was number 5. Okay, let's go over answers to 2, 4, 6, and 8. Number 2 was -3. Number 4 was 144. Number 6 was 5, and number 8 was 16/3.
Whoa.
Which is what, 5.3 repeating?
Whoa.
You have one you want to go over, Caleb?
Well, I did get 6 and 8 wrong.
-3 for 2, 144 for 4, number 6 was 5, and 8 was 16/3. So, any of those you'd like to go over? 8?
Yeah.
Okay. So we're putting 2/3 here, right? So 3 times 2/3 squared minus 3. Well, 2/3 squared is 4/9. All right, and that becomes 4/3 minus 9/3, which should be -5/3. What did I say it was?
You said 16/3, and I got 9/3.
Yeah. So you got 16/3. That's the first half, right?
Oh,
Right? So we're not done yet, right? Now I'm putting the -5/3 in again, right? So 3 times -5/3 squared minus 3.
Oh, you used 1.
Right. Now that's the first answer right there. Now let's see what happens when we do it again. So that's 25/9. When I square both of those, and negative times negative is positive. And then that reduces, when I multiply 3 times 25, 75 divided by 9, it reduces to 25/3. Just divide both by 3. And then again, 3/3 is 9/3. And 25 minus 9 would be 16. So maybe you just didn't do the second part.
I didn't.
Okay. Anything else? 2 through 8. Okay. Number 12 was, what did it say? Find f of g of x and g of f of x. And f of x. All right? So there's 3 problems for those. So A was 4x squared, or the f of g of x is 4x squared plus 20x plus 32. The B, g of f of x, is 2x squared plus 19. And the C, f of x, is x to the 4th plus 14x squared plus 56. Domain, anything works, all real numbers. All right? Then we did what? 14? Is that next? Or just 16? 16? All right, let me find this. It's in the additional answers part. This is section 5-6, right? Number 16 was the next one. F of g of x is 4 times the quantity, not the quantity, 4 times the square root of x minus 6, and then plus 2. And then x would your domain, since it's a radical and it's even radical, just like on our inequalities the other day, you got to do that x minus 6 is greater than or equal to 0. So that would mean x would be greater than or equal to 6 for your domain. G of f of x is the square root of 4x minus 4. And then you set that greater than or equal to 0, and when you solve for x, you get x is greater than or equal to 1 for your domain. F of x is 16x plus 10, and anything works for your domain. Did we do 18 next? Was that the next one? We did 12, 16, 18,
Yeah.
and 19. Okay. 18, f of g of x is negative 6 times the cube root of x plus 4, and then a minus 5 on the end. For g of f of x, it's the cube root of negative 6x minus 1, and f of x is 36x plus 25. Since it's a cube root, we can have positive and negative numbers underneath that radical. So all real numbers work for a domain. 19, f of g of x is 2x squared plus 12x minus 19. G of f of x is 4x squared plus 16x minus 3. And f of x is 4x plus 3. And again, we can use any number for x, so all real numbers work for the domain. So I'm sure there's at least one question on one of those. Or maybe we should go over those. One of those.
Can you go over 12?
Sure. Okay. So the first is f of g of x, right? So we're doing f of 2x plus 5, right? We're putting the g of x, the 2x plus 5, in the f of x. So wherever x is, which is the first x, I want to do 2x plus 5 squared, and then the plus 7. Don't forget about the plus 7. So I got to square that binomial. How do you square a binomial? FOIL it, right? So first is 4x squared. Outside is 10x. Inside is 10x. And last is 25. So combining like terms, that's the final answer. We don't have a number answer because they didn't give us a number for x to put in. Does that make sense for that one? Okay, the second part, B, you're doing it the other way. You're taking this f, x squared minus 7, and putting it in the g. Or next, plus 7. Did I say minus 7? All right. So I'm going to go 2 times, and putting x squared plus 7 in for x, and then plus 5. So this one's a little bit quicker because all I have to do is distribute the 2, right? You get 2x squared plus 14 plus 5, which is 2x squared plus 19. The third one, you're putting x squared plus 7 in for x, right? You're doing f of x squared plus 7. So you've got x squared plus 7 squared, and then plus 7. So you've got to FOIL the x squared plus 7. And then plus 7. So that's what you're doing when you square it. So first is x to the 4th. Outside is 7x squared. Inside is 7x squared. And last is 49. And then combine like terms. So we got x to the 4th plus 14x squared. What's that? 56. So there's your three answers. This one, and that one. So that's when you're substituting in a whole function in for x. So it's an expression when you're done. It could be a trinomial, binomial. It's not an actual number answer like the first one. Okay? What do we call this again? Composition of functions. It's not hard, it's easy.
Yeah.
If we're paying attention and not messing around in our wall and stuff.
think I got it nailed down.
Okay, any others that you still would like to go over though?
Huh.
We can still go over it. Okay.
18.
18? All right, all three parts or just which, a certain part?
All three.
All right, number 18. Let's see if I can pull it out here. So we got more room. All right, so the first one is f of g of x, right? So wherever I see an x, that's 18, right? You guys said -6 times the cube root of x plus 4 minus 5. Basically, that's all you can do. You can't simplify anything. So it's just, if I drop the parentheses, I'm done,
Yeah.
right?
Pretty much.
Okay, the second one is g of f of x. Okay, so I'm putting this for x in the g problem. So I got the cube root. Instead of just an x, I got this -6x minus 5 minus, oops, yeah, minus another 5. I was looking at the wrong one. Right? So I put this, -6x minus 5. Oh, I was looking at the wrong one still. I need to add 4, don't I? Sorry about that. I'm putting it in there. So I put the -6x minus 5 in the x and then the plus 4. And then you just simplify it. -5 plus 4 is -1. And then the f of f of x so I'm putting -6x minus 5 in for that x. So -6 and then -6x minus 5 minus 5. So I distribute the -6 and I get a positive 36x plus 30 minus 5, which is a 36x plus 25 when I simplify. Don't have any radical this time. It's just f of f again. So today we're going to talk about inverse of functions. Okay. So basically we're solving for x and y today. All right? So it says you can solve equations of the form y equals f of x for x to obtain an equation that gives an input for a specific output.
Solving for x and y today. That means that you have to remember.
You got 4.
You did.
No,
I mean, I didn't think I did that. Okay, thank you.
I just forgot to put the rest of it.
You really gotta solve it.
You're welcome. All right, so remember, f of x, another way to write function notation is in our normal equation. I could rewrite this as y equals 2x plus 3. So that's what this is saying. Solve y equals f of x. All right, so they want, instead of writing f of x equals, they wanted you to write y equals 2x minus 3, or plus 3. And then solve for x. So what do I got to do first to solve for x? Again, solve for x means to do what? Get it by itself. So what do I got to do first?
Add 3.
Not add 3.
Minus
Yeah, subtract 3, right?
minus 3.
And then what? Divide by 2. Now, since you don't have to graph this, the easiest thing to do is just make a big long fraction bar. And leave it like that. If you have to graph it, which you'll have to maybe do on a couple problems, you should make this 1/2 y minus 3/2. Because then you know your slope and your y-intercept, right? But you don't have to do that if you don't have to graph. Okay, Sydney? So then it says, then find the input when the output is -7. So which variable is the input variable? Which variable is the output variable?
X is the output. Input.
Yeah, x is the input, y is the output. All right? So all right, so they want us to put -7 in for y and figure out the x. Well, that's -10 divided by 2, which equals what? -5, right? Okay, so when you see that type of problem, it says let f of x equals 2x plus 3, solve y equals f of x. That just means to put y in place of the f of x, and then get x by itself. And then whatever number they give you, output, put in for y, and figure out your x. That make sense? Any questions? All right, so on this one, I'm going to rewrite this as y equals -x cubed plus 3. Right? So what do I do first to solve for x? Subtract 3 again, right? So how do I get rid of that cube? Right? Mason? Cube root both sides. All right? So that's -x, right? And that's the cube root of y minus 3. So how do I get rid of that negative sign? -1, right? Which means just put 1 out front, right? So that's solving for x, and then it says when the output's 2, all right? So I got negative the cube root of 2 minus 3. What's 2 minus 3? What's the cube root of -1? Itself. Yeah, -1 in that case, right? -1 times -1 times -1 is -1. And 2 negatives make it a positive x, or a positive 1. All right? Making sense how to do that problem? We're getting close, but not quite yet. Okay? Let's do this one. Go ahead and start. Do it on your own here, and start solving for x. You guys should have the first step done, which was what?
Evening it out.
Yeah. What's okay? The second step then from here. What's to get x by itself? What are you gonna do? Okay, so do that step. So you should be as far as I am. Now, what should we do? Well, what's easier when you're dividing by a fraction?
Oh, man.
Connor, louder. Right, multiply by the reciprocal. So let's multiply by -5/3. Now remember, it's everything gets multiplied by -5/3. Okay? Sometimes we forget to multiply the -5/3 times the 8. So don't forget that part. So on the right side, we get an x, right? Because the -3/5 times the -5/3 is a +1, right? That's what we want. +1x there. So then we got -5/3 y minus 5 times 8 is 40. Remember, it's just the 8 times the 5, not both of them. It's just over 3. It's like 8 over 1 times -5 over 3, right? 8 times -5, 1 times 3. Okay? And then you're supposed to put -1 in for the y. What's a -5/3 times -1?
5/3.
+5/3. So what's a +5/3 minus 40/3?
45/3.
-35/3.
I was joking.
All right. If you have to put that in your calculator, that's okay. Just put your fractions in parentheses. All right. So those 3 examples making sense? So you're writing, changing it from f of x equals to y equals, right? And solve for x. All right. So this is how you do inverses then. Okay? So here's our first example we already did today. Right? We had the 2x plus 3, and then we got x equals y minus 3 over 2. That's the first one we did, right? Okay. What we just did there is those 2 things, we just undid those. All right? When you undo each other, you're doing the inverse function, or you're finding the inverse of the function. Okay? The symbol for f inverse is this. That -1 exponent means the f inverse function. Okay? So it says this last sentence. Because an inverse function switches the input and output values, the domain and ranges are also switched. Okay? So here's what happens. If you look at, if you were to try to graph this, I know you guys could go to the y-intercept of 3 and then what with your slope? Up 2 over 1, right? But if you substituted -2, -1, 0, 1, and 2 in, -2 times -2 is -4 plus 3 is -1, right? Oops, why did it do that? Come on. I want to let it move. Maybe it doesn't want to move. It did. There we go. What's 2 times -1? -2 plus 3. Let's pay attention, please. +1.
Yeah.
What's 2 times 0 plus 3? 3. What's 2 times 1? 2 plus 3. 5. What's 2 times 2? 4 plus 3. 7. See that? Okay. Now here, what if I go -1 minus 3? I get -4 divided by 2 is what? -2. 1 minus 3 is -2 divided by 2. -1. 3 minus 3 is 0 divided by 2. 0. 5 minus 3, 2 divided by 2. 7 minus 3, 4 divided by 2. What do you notice about this row and that row, the top row and the bottom row? They do what? They switch each other, right? That's what happens with inverse functions. Okay? The domain becomes the range, and the range becomes the domain. That's what they wanted to show you there. All right? So the graph of inverse of f inverse is a reflection of the graph of f. The line of reflection is y equals x. So there's the two graphs. Okay? The blue one is one with the blue table. The red one's the one with the red table. That dashed black line is the y equals x line. Always inverse functions are reflected about that y equals x line. Okay? Here's what you got to remember. To find the inverse of a function algebraically, switch the roles of x and y, then solve for y. All right? So, looking at that first example, it was y. Oops. It was y equals 2x plus 3, right? To find its inverse, you just rewrite it as x equals 2y plus 3, and then solve for y. That's all you have to do to find an inverse. Just rewrite it. X equals 2y plus 3. Switch x and y, and then solve for y. So you're going to subtract 3, and then divide by 2. Okay? So that's the inverse of this. Those are inverses. Does that make sense? Okay? It's that easy. You guys know how to solve for y. All you're doing is switching the x and the y value. You know, those letters. And then go from there. All right? So it says find the inverse of the function, then graph the function and its inverse. All right? Well, let's just graph that one real quick. Where do I start? -1, right? Then what? Up 1, 2, 3, and over 1, right? If I went down 3, I got to go left 1, right? What happened? I went below, I guess. Okay, to find the inverse. Remember, this was the y, right? So I'll make that the x the y, add 1, right? And then what? Divide by 3. So remember, if you want to graph it, that's what it is, right? When you separate them. So what's my y-intercept? 1/3, which is about right there, right? And then what do I do from there? Up 1 and over 3. So go up 1 and over 1, 2, 3. Or if I go down 1, I go left 3, right? So there's that one. The y equals x line is that. Are they reflections about there if I fold it? Yeah. That's how you do that problem if they ask you to graph it. I graph it right away, the one they give you, then switch your x and y, your y by itself, and then graph that. Okay? Get it? Got it? Good? Look good? Feel good? You are good.